Welcome. Recently, I've begun playing around with 3D printed electronics, specifically 3D printed PCBs using a combination of PLA and conductive PLA. You may have seen images like the one in the bottom corner here. The black material is conductive PLA and the green material is just a substrate for holding the conductive material in place. And this video is to showcase my plan towards creating a 3D printed PCB based on this simple circuit where we have a battery, a resistor and a light emitting diode. So we've got 6 terminals in this circuit. We've got 2 at the battery, 2 at the resistor and 2 at the light emitting diode. This Instructables workshop page called 3D printed PCB is a nice summary of someone else's work in attempting to create 3D printed PCBs. In it they describe some of the supplies they've used, some of the problems they had, how they attached components to them, and even some testing work they did. So they using different thickness of conductible PLA. Down here they've concluded that the bigger the track volume, the lower the resistance, and they used a track width of 3mm. So for this introduction I'll be using 3mm as well. Down at the bottom is my sketch for the 3D printed PCB. We've got 6 terminals, so each component will go in between these wires. To make better use of space, I could have stacked them in a column arrangement, but I prefer the hexagonal arrangements of the wires. It just looks nicer for me. So the workflow will consist of creating the base and then creating the layer of the wires separately. And I'll explain why as we go through the video. So let's head into Solvespace and get started. First, let's create the base, and for that I'll need to select the line segments tool and create a rough hexagon. We've got 11 degrees of freedom, so let's add some constraints. I want this line to be horizontal and this one, and I want all the lines to be equal, and I can do that by selecting 2 lines and then clicking here, constrain equal length. We need to now constrain the internal angle of the hexagon. To do that, let's select these 2 lines first and click here and type in 120. But we need to constrain one of these 2 opposite corners now. Let's select these 2 lines. And let's make the distance between these 2 lines 120 degrees as well. 3 degrees of freedom left. And that is because I can change the size of this hexagon and move it in a 2-dimensional plane. Let's change the size of it first. I want this side to be 20mm. And I want the origin of the plane to be in the middle of the hexagon. And to do that, what I'll do is select the line segments tool again, click on this point, and drop it on here. You'll notice that the points will turn yellow when it's time to click, and it's complaining that we haven't got a closed contour, but I don't need the contour. I just want to convert this line into a guideline by clicking toggle construction, and then I want the origin to be at the midpoint of this line. So I'll select the origin and the line, click M on the keyboard, and now we have 0 degrees of freedom. A nice touch now would be to give this base some rounded corners. Let's do that. I'll select one of the corners and click here, create tangent arc at selected point. And now I can do the same for the rest. Let's constrain them all to be equal. So I'll select this rounded corner and this one and click here, constrain to have the same length or the same radius. And let's do it for the others. Now you'll notice we've got 1 degree of freedom, and that's because the last thing we need to do is specify the radius of the rounded corner. Let's make it 5mm. Select the corner, click here, constrain distance, type in 5. I think that looks a little bit better. Okay, 0 degrees of freedom, let's extrude that, and let's give it a depth of 3mm. So I'll select one of the extruded axes and type in 3mm. Click W on your keyboard, and that's the base done. Let's save it. Let's go to File, Save As, and I've called mine Base. And I'll convert this now into an STL file. We're going to File and go down to Export Triangle Mesh, and I'll call this Base Print. Okay, let's move on now and create the wires. Go to File, click New, selecting the Line Segments tool now. 2 parallel lines. Let's make this one horizontal. Let's make them equal. Select them both and click Q on the keyboard, or you can click here to select the arc tool, and let's put 2 arcs on either side. Now we've got 7 degrees of freedom. We need to constrain the position of the lines relative to each other now. So I'll select this point and this point. I'll make them vertical to each other, and I want the length of the line lines to be 3 millimeters. Selecting the circle tool, highlight the center of one of the circles and pull out. Doing the same on the other side. Let's constrain these circles to be equal, and I want this inner circle to have a diameter of 2. Now, because I want the thickness of this terminal to be 3 millimeters, I want the outer diameter to be 8 millimeters. Degrees of freedom left, and that's because I need to constrain the wire thickness, or the distance between this point and that point, and I want that to be 3 millimeters also. 2 degrees of freedom now because it's not anchored. So let's anchor it at the origin and click constrain point on point. Okay, we've got 2 more of these wires to do. So I can select this one, go to edit and copy, and then edit again and go to paste transform. Now you'll notice in the properties panel, we can do things to this object before pasting it, and we want to rotate it by 60 degrees. And then I can click paste transformed now. And let's do the same thing again. We've got 10 degrees of freedom. Let's see why. Well, I can click and drag this. You'll notice there's a lot of movement here as well. And over here, for me, my workflow was to select the line segments tool and create another hexagon, joining these up. Okay, we have our hexagon, but it's not perfect. Let's convert the contour lines now into construction lines. So I want this line to be horizontal. Selecting it and click H. Let's make the lines all equal now. So let's select these 2 lines and click here, or Q on your keyboard. And I'll do the same now for the rest. But the internal angle of the hexagon needs to be constrained. Let's do that now. I'll select this line and this line, click here, constrain angle, and type 120. These 2 lines need to be constrained as well. So click on constrain angle, type in 120. These 2 lines are equal to each other, but I want them to be parallel with relation to this construction line. So I'll select that construction line and this line and click here, and the same on the other side. Now we've got 0 degrees of freedom. I can extrude this model and I can give the extrusion a depth of 3 millimeters. And that's the wires done, I think. Yeah. Let's save this. I'll go to File, Save As, and I'll call this Wires. Now we've got 2 models, the model for the wires and the model for the base. And that is because the printer I'll be using has 2 extruders on it. I want one extruder to print the base and the other extruder to print the wires. But we need to make sure that the wires position properly relative to the base. And let's do that now. Go to File, click New. At the menu bar, find New Group. Click on it and go down to Link Assemble. A pop-up window will appear, so I'll click Base. These arrows pointing out from the points are normal lines. Before I constrain the position of the base, I want to make sure that it will be orientated correctly. So I'll select one of the normal lines, and then let's click the Z-axis normal line, and then click here, constrain normals to be in the same orientation. Let's anchor the base at the origin, and we've got 0 degrees of freedom. Now let's bring in the wires model. Let's do it again. In the menu bar, click on New Group and go down to Link Assemble, and then I'll select Wire, and it's placed it at the top of the model here. If yours isn't, you can click and drag at one of the points and drag it outwards. I'll select a normal line here on the wires model and the Z-axis normal line, and then click constrain normals in same orientation. Now we can move the wire model to be flushed with the base. I'll select this point. You can select any other point at the bottom of the wires model and the face, and click constrain point on plane. Now, because the purpose of this sketch is to correctly position the wire model at the correct height relative to the base, and the base is fine now, I can select the base in the properties panel. I can click here and click delete and OK. I want the origin to be in the middle of this hexagonal arrangement of wires. What I want is a construction line, and then I want this origin to be at the midpoint of the line. So select them both and click M on the keyboard. We've got 3 degrees of freedom, and that's because we have some rotational freedom here. And what I've done is I've selected the horizontal guideline and the y-axis normal and constrained the angle between them to be 90 degrees. I'm going to start converting these now into STL file. Go to File and go down to Export Triangle Mesh, and I'll save this as wire export. Finding the base model file, I'll click and drag it into Cura, and I'll do the same thing now for the wires model. I tell Cura to print the base using nozzle 1 and the wires using nozzle 2. I then select both objects and click merge and then slice, and the model is now ready for printing. Now let's take a look at the 3D printer printing out this model. The printer I'm using is a 10-log TL-D3 Pro, and I've put the website down there. So on the first extruder I've just got normal PLA, and on the second extruder I've got the conductive PLA by Protopasta. After looking at the print, I noticed that the printed wires are not placed perfectly at the center of the hexagonal base, so I may need to do some calibration on the 3D printer. Next, let's take a look at the conductivity of these wires using a multimeter. So I'm setting up the voltmeter to measure a resistance of up to 2000 ohms, and then I'll go through each terminal one at a time. The resistance seems quite high across one of the wires, roughly 500 ohms, similar with the other two wires as well. And what I'm doing now is making sure that there's no connection between the wires, so see if there's any bridging going on between the wires, and it doesn't look like there is. So it seems that the wires have fairly high resistance. That means I could probably directly connect a light emitting diode to the battery. So I guess the best way of finding out is to actually connect some components. To summarize what I've covered, decided on a simple circuit. I looked at using Solvespace for creating the STL file for the base substrate and the wires, and then Cura for combining the models ready for 3D printing. Once the model was printed, I tested the resistance of the wires and found them to be quite high, much higher than a normal wire. And in the next video, I'll be figuring out how to attach the components to the wires and seeing what happens. So see you in the next video. Bye.